Topic of this video is review, starting a new chapter, but the following functional groups, or review what they are. So alcohols, draw some example alcohols. Etc. There's lots of those. What all the alcohols have in common are those OH groups. Those OH groups are also called hydroxyl groups. Those are alcohols, but hydroxyl is used as well because when we look at polyfunctional compounds, biomolecules especially, when you've got molecules that are, for example, amino acids. Some amino acids have an alcohol functional group, carboxylic acid functional group, and amine functional group. They're polyfunctional. So the hydroxyl is just used to point out the OH group. Now, this is not to be confused with compounds like so. These are not alcohols. They are carboxylic acids. During office hours this semester, some folks have gotten ketones and amides and things like that mixed up. A functional group is classified once. Okay, this region that I'm circling in red, that is what makes those carboxylic acids. Okay, that is not both a carboxylic acid and an alcohol. It's not. The functional group is classified once. Okay. The carbonyl, the carbon-oxygen double bond next to the OH. In other words, the carbon atom that I'm highlighting there that's bonded to two oxygen atoms. You've got to have that. And it's a carboxylic acid. So it's a common mistake to confuse these two functional groups. Carboxylic acids have a carbonyl. Alcohols do not. Ethers. Some example ethers. It kind of looks spider-like in some examples. They are ethers in a way that you can remember it is they have alkyl groups, that is carbon-containing groups on either side of an oxygen atom. Okay, it's hokey, but those are ethers. Oxygen atom, alkyl groups on either side. Okay. Common mistake made with confusing ethers with esters. Okay, they both start with E, but an ester has the carbonyl in it. Again, trying to distinguish these are not ethers. They are esters. Okay. Ester, the chemical functional group ester is spelled without an H. But again, notice you've got to have an oxygen atom. Carbon atom bonded to two oxygen atoms and a carbonyl present. Okay, so notice the difference there. Ethers are not esters and esters are not ethers. They're distinct. alkyl halides. It's an alkyl chloride. It's an alkyl bromide. It's an alkyl diiodide, etc. Okay. Those are alkyl because they have some carbon-containing group, and a halide because they contain algae. Pretty straightforward. And then thiols. They are sulfur alcohols, so to speak. The way you kind of remember that. But you don't have to show that explicit sulfur hydrogen bond. You can show it condensed, like the structure on the right. But instead of oxygen, you have sulfur instead. A thiol is sulfur instead of oxygen. These are examples. There's many more. Sulfur contain thiols in general, rotten egg kind of smell. Thiols are stinky. They have an unpleasant aroma. They are put in. It's a common mistake to think that natural gas or propane have odors. They actually don't. They're odorless. It's just that they are spiked with small amounts of methane thiol, I think. But a small amount of the thiol-containing compound, because our noses are really sensitive to that pungent kind of rotten egg smell. So if you smell a gas leak in your house or outside your grill or your gas grill, what you're smelling is a thiol that has been laced, that is mixed with your alkene gas that you're using for combustion. But there should be a review. These functional groups have been covered, but you've got to keep them straight. Carboxylic acids and alcohols are different from one another. Esters and ethers are different from one another, and they differ in whether there's a carbonyl present or not.